Welcome to Stoichiometry Part 2, where we deal with compounds where the amounts are given not only in units of mass, but also gases in units of volume, and the gases are at STP. This refers back to class notes 19 if you're keeping score. If you are unfamiliar with stoichiometry problems or need a little refresher, please look at Stoichiometry Part 1, where we deal with the amounts given only in mass. So, how do we solve a problem when some of the amounts may be given in volumes, specifically volumes of a gas? And this is very important. Well, for mass, we looked at molar mass. Remember, mass was our key word back at class notes 13 for molar mass. But remember, also we had another keyword, STP, or standard temperature and pressure, which gave us another unit factor, specifically 22.4 liters of a gas per 1 mole of gas. We will be using this unit factor in our problems to solve stoichiometry in this particular video. As we did in Stoichiometry Part 1, we will build a step-by-step process by which we will solve our problem. We will start again with step 1, balancing our reaction. Whenever we have a chemical reaction, it must be balanced before we can use it. Only then can we actually solve for the products or reactants, whichever we need. Here I've come up with a problem dealing with, again, liters or volume of a gas. So 6.7 liters of oxygen gas reacts with CH4, that's methane, to produce carbon dioxide and water. And the question asked is, what mass of water is produced? So again, we will have to use some of the skills we developed in Part 1, or if you need to go back to earlier class notes, please do that. And that is, we have to translate all the things that are in chemical names or compound names into formulas. So I've already done that. CH4, well, that was already given as a formula. Oxygen gas, I have to know that it is a diatomic, so it's going to be O2. CO2 is carbon dioxide, and water is H2O. Now, this first reaction is not balanced. If I have to, I will go back to class notes 17 and look at how to balance chemical reactions. I've already done that. I went ahead and put the new coefficients for both oxygen and for water. And now this chemical reaction is balanced, and I can go ahead and use that chemical reaction when solving my stoichiometry problem. Now, on to step 2. We've got our balanced chemical reaction. I went ahead and included it down here. Now I want to look at what are my units and label of my answer. That is, what am I looking for? And how can I write it in such a way that I can use it in my calculation to figure out where I'm headed? Okay, well, let's look at this statement here. What mass of water is produced? Well, what are we looking for? The mass of water. Another way to write it in a way that's going to be helpful for our calculation, mass, probably the best way to express mass would be grams, or G, and mass of what? Water. And again, I'm going to write it in as my formula, H2O. So the units and label of my answer are going to be grams, or G, of H2O. In using a chemical reaction, I will link two compounds that I'm interested in together. That is, two compounds of interest. And I will do this using a mole ratio. We saw this in Part 1 as well. So, which of the 4 compounds do I have down in my balanced chemical reaction do I need to link together? Which of the 4 are my compounds of interest? Well, again, the first one's easy. That I will get from the label of my answer. Remember, we found that in step 2. So one of my compounds of interest is H2O. But what about the other compound? Well, I know something about my oxygen gas. I know how many liters of oxygen gas. So that's going to be my other compound of interest, oxygen, or O2. I will use the coefficients of the balanced reaction to generate my mole ratio. That is 2 moles of O2 to 2 moles of H2O. In other words, 2 moles of oxygen are consumed to generate 2 moles of H2O. This is my mole ratio, and it will become one of my unit factors when I assemble all my unit factors together in step 4. Now moving on to step 4, finding the unit factors. Before we get started, I want to note this addition I've made to my problem, assume STP. In this class, you will be given that statement, assume standard temperature and pressure if you need to use the STP unit factor. Our first unit factor we've already calculated. We already got that from step 3, finding the mole ratio of the 2 compounds of interest. So I'm just going to repeat it right there in pink. Some more items of information. If you have class with me, you'll know that I love to use the color green for plain numbers. And I put that also in green up here in our problem statement to kind of highlight that. How to write a plain number. Our plain number is 6.7 liters of oxygen, O2. And I went ahead and put it 6.7 liters O2 over 1, which is how we write our plain numbers. Also, in addition, I went ahead and shortened our problem by going ahead and writing the formulas instead of the compound names, since we've already done that. Assume STP gives us our third unit factor. Remember, 22.4 liters of O2 per mole of O2, per 1 mole of O2. If you don't remember that, you can go back to class notes 13, where we first talked about the STP unit factor. So where do we get our fourth unit factor? Well, remember in step 2, we had our answer. It had a unit and then it had that label. Our unit, grams, is a key word, again, if we go back to class notes 13, for molar mass. Molar mass of what? Molar mass of water, which we calculate as 18.02 grams O2 per 1 mole of grams of H2O per 1 mole of H2O, the molar mass of H2O. Now for step 5, let's go ahead and finish our calculation, assembling our unit factors so that, let's remember our goal, that the units and label on the right-hand side, that is our answer, look exactly the same as the units and labels once we finished all our cancellations on the left-hand side. So I'm going to start off by saying which of my unit factors looks most like my answer. That is in terms of units and label. And I'm going to choose my molar mass of water, H2O. Why? Because it has grams H2O in it, just like my answer. I like the way it's written. I'm not going to flip it because I want to start off by matching my first unit factor on the left-hand side to my answer on the right-hand side. It has a friend, mole H2O, that has to come along, so I'm going to put that there. I like the grams H2O. It looks like my answer, but I need to get rid of moles H2O because it's not over here. I need to find another unit factor with the moles H2O, this time on the top, so that they can cancel. And what I find is from step 3, my mole ratio, 2 moles H2O to 2 moles O2. And again, I like the way it's written. I'm going to place it right there. And now I can cancel out the 2 moles of H2O. Here and here. But again, my mole ratio comes with a friend, moles of O2. I need to get rid of that unit factor. So I need to find one more unit factor that has moles of O2, this time with moles of O2 now on the top. I have my STP unit factor. Now I need to flip it so that my moles of O2 are on the top, and I can now cancel out moles of O2 with moles of O2. Well, it also comes with a friend, liters of O2, and this is an L, liters of O2. I need to get rid of it, so I'm going to use my plain number written the way it is because liters of O2 are on the top, and that will cancel with my liters of O2 on the bottom. Once I've done all my calculations, I see, all my cancellations, I see all my unit factors on the left-hand side, grams of H2O, are the same as my answer, grams of H2O. So I go do my one-step calculation, and I find, one-step calculation, we can't forget, our significant figures. So significant figures here, I have 2. Here I have 3. That's for my STP unit factor. Always remember our mole ratios are exact, and there are 4 unit factors for our molar mass of H2O. Once I've done my calculation and I've done my rounding appropriately to 2 significant figures, I find 5.4 grams of H2O. So I finished my calculation, and this particular stoichiometry problem is done.